XML was designed with a number of goals in mind. One of the most important, for purposes of this class, is it was designed to provide data transfer that's platform independent. What does that mean? Well, the idea here is that you can have a producer app that's written in any programming language, on any operating system, and any type of hardware, and a consumer app implemented in any other programming language, operating system, or hardware. There is no binding between how the consumer app or the producer app is implemented, because they both agree to speak XML to one another. And of course, in addition to consuming XML from the producer app, the consumer might also write XML to the producer app. Another important goal for XML is that it would be easy to write programs to read and write XML. The designers also wanted a data format that could be validated. So in XML, we write a specification for a particular type of document, and then any specific examples of that document that are produced can be validated against that specification. So Biomed Central has a specification for the research article format, and any articles that are produced are validated against that format to ensure they adhere to the rules for that data model. XML is designed to be human readable, and as we saw in the example, we can get a pretty good idea of what information is contained within an XML encoding just by looking at it. And finally, XML is designed to support a wide variety of applications. We've seen one application of XML. We're going to take a look at several others that essentially span a number of different ways in which XML can be applied to exchanging data between applications. If you're interested in more information about this data format, I encourage you to take a look at the W3C site. We're going to talk a little bit about what having a standard means. One of the most important benefits of there being an XML standard is that we have robust parsers in most programming languages, Python included. What this means for us as data scientists is that we get to focus on our own applications. We don't have to worry about writing parsers for some ad hoc data format. Previously, each messaging system had its own format, and all were different, which made the type of messaging that we do now very messy, complex, and expensive to do. If everyone uses the same syntax, it makes writing these systems a lot faster and much more reliable. Another advantage for XML is that it's free. Now, that's free as in beer, but also free from legal encumbrances. It's not a format that any company owns and may change out from under us. XML information can be manipulated programmatically. So we can build databases to support specific types of queries. Or we can piece together data from different sources, or take it apart to be reused in different ways. XML documents can also be reliably converted into other formats with no loss of information. XML lets you separate form, or appearance, from content. So your XML file contains your document information, all of your text and data, and identifies its structure. Formatting and other processing needs are identified separately in a style sheet or processing system. In the Biomed Central example, it is actually that XML that is transformed into HTML for rendering on the website or into PDF for download using a style sheet and style sheet processing system. The two are combined at output time to apply the required formatting to the text or data identified by its structure. This structure might define location, position, order, or any other aspects of the data.